take energy during off-peak and store it and reintroduce it into the grid. They can also do it at residential level, community level, anywhere you want to. So all of the players in this group together have a, really are going to have a monopoly on, how to treat, store, and forward energy. So what this will do to like the power company, right now the power company, when it's peak time, they'll have to work over capacity, and then at night they have to throw away energy. So what we, with the store and forward, we allow them to do is continuously produce the same amount of energy and handle it further down the grid. So it saves them operating costs. The power plants last longer, the grid will last longer. And then there's other little tricks we do that we'll show you in just a second. Flyback. These are the people that capture the inductive and capacitive losses and put them back into the next part of the sine wave, and they actually create, take lost energy and almost create fresh energy. So it means that instead of losing 10%, you only lose 2% on your conversion. So by far the most efficient in the world, no EMIs, no harmful high frequency, it's all done in low frequency. And typically 4 to 8% increase in usable power over anything that's out there. And it's patented technology, and it's ready to hit the market.
From the design of that, is it actually tracking the wind and spinning in the direction of the wind?
Our unit actually tracks the wind. It has like a stabilizer, if you will, that's similar to a traditional windmill, and it will pull itself into the wind.
Okay. What is your dimensional size of that?
The 1500 watt unit is 1.6 meters, a little less than 6 feet.
6 feet. Do you have cost on it?
I do. I have production costs. We haven't. Our production cost is below $1,000, so it's just a matter of building it up to consumer level and how many steps are between.
Oh, okay.
But it's lower than most traditional windows.
And in a residential location, are you looking at rooftop or poles, or what are your options for residential as far as mounting?
Any of the above. It depends on the wind pattern. So depending on the wind map for your area would determine what elevation you would need. And in many cases, if you have a reasonable amount of wind, it could be rooftop, or if you need to go higher, it can be on poles.
Okay.
For the power companies, we're actually going to be located on top of the transmission towers, which is wasted space and it's ideal for wind.
Would you say the overall size and mass of it for a residential installation is going to require, if it's on a pole, guide wires, or can it be on a standalone pole?
Again, that depends on the engineering study for the soil and everything else. I can't answer that without knowing the specifics. Because if the ground is solid enough, you can pour some concrete and have a solid pole. If it's too soft, you're going to have to use guide wires.
Gotcha. Okay.
But that's nothing different from traditional windmills. It's just more efficient at the output power, smaller size per output power. Ecolite, that's again the manufacturer of our wings, and they've done a tremendous job. The wing is actually made out of straight, it has this really fancy curve. It's made out of straight pieces of aluminum that are all slotted and sliced together, similar to an aircraft wing, but then it's the wing that's twisted. And it's just truly amazing how this engineer managed to take the design and convert it. Because the first prototypes were made out of fiberglass. We did some, it's a laser that writes stuff in polymer and actually becomes something. We've done that. It's very expensive, but works very well. But for production, it's actually going to be an aluminum frame that's going to be covered initially with some sort of a fabric. We're talking to some carbon fiber people to actually put a carbon fiber covering, but the only problem with carbon fiber is lightning. So we're weighing the pros and the cons on that. So in a nutshell, this is these are the companies, and so we're really dealing with the power plant developer. They are helping us be more efficient even. These guys, the CPV is what they also manufacture. We have the rights for the CPV to manufacture it in different places. We're negotiating with the Turkish government. We're working with a company in Europe to build it, and we may also build it in California. But basically what they do is they supply little modules, and then we're going to be building the rest of it. And of course, demand energy. And the next slide is a little bit clearer. We produce energy, but it's a tracking system. This is a 2-axis tracker. Single-axis tracker looks similar to this, but it is 80% of the efficiency of this guy. This is half the size typically of traditional solar, also half the price. Traditional solar, so Kevin Solar is a perfect match for what we are trying to do. We can store and forward, or we can deploy directly, and then this guy is also inside of this. So we're using the most efficient technology